everybody. My name is Tanner McFarland. I'm an engineer in our product development group here at ACT, and I'm here to talk a little bit about ram air heat exchangers. So to start off, the way a ram air heat exchanger works is when you have some sort of vehicle, typically an aircraft, moving at a high speed, you effectively have flow of all the cool air around it. And when you have an aircraft, it's sometimes very difficult to cool down some things on the inside because really the only way you can reject heat is from the exterior surfaces. So kind of a good way to get around that is to use some of that external air and flow it through your aircraft so you can have kind of a secondary area to reject heat. So the way these work is because you're going at a high speed, you have your kind of ram air inlet, which I'll just draw here for now. And then it goes through a pressure diffuser. Since you have a very high effective air velocity at the inlet, you need to kind of slow it down to build static pressure. Bernoulli's principle kind of shows that when you have a high dynamic pressure, you'll have a low static pressure. So by slowing the air velocity down, we decrease that dynamic pressure to increase the static pressure. So we kind of go through our air diffuser, changing cross sections to do what I just said to build the static pressure. Then you have your main kind of heat exchanger portion, and then you have your air outlet. And the air outlet, because you're kind of behind an aircraft, you have a low pressure zone. And so with that, you have your low pressure outlet, and then your high pressure inlet. And from that gives you kind of an induced flow from a pressure difference. So then the important thing to actually design, on the inside here is your heat exchanger geometry. Typically these can be some sort of vacuum brazed assembly or in simpler cases an epoxied fin assembly or a couple other different manufacturing methods. But with aircraft especially, there's some different things you have to consider. Depending on your flight altitude, that can change your air properties drastically based on temperature, your air density, and viscosity. So typically there's a good amount of analysis that gets done on the fin geometry here. I'll just do a little squiggly to indicate that. And there's a good amount of consideration that has to be done there. And in terms of what you can kind of use this to cool down, some aircrafts have a lot of high electronic components that you might have conduction, bringing heat to an exterior wall here, or maybe some other fin geometry. So you could have some sort of conduction chassis that gets mounted to this, where heat kind of goes in, and then you have your cold air in, hot air out. Or you could use an air-to-air heat exchanger to help with some sort of cabin cooling system. So there's a lot of possibilities. This is a very brief explanation of it, but hopefully this is something that you guys can consider in your aircraft design or other vehicle design. And thank you guys for checking out this video. For more information, go on to Advanced Cooling Technologies websites or YouTube channel to see other videos like this.